Hello everybody, welcome to session 1, chapter measurement. The objective of this video is to define measurement and explain its importance, to describe different types of physical quantity, to define unit and explain its types, to find fundamental units involved in derived units. Measurement. In our daily life, we measure different things, like if you are taking medicine, then we say, okay, you take 2 tablespoons of medicine. Or if we go to market, then we buy 2 kilograms of, let's say, rice. If you go for like a weight, then you can buy 2 pounds of, let's say, milk, something like that. So if you go to school, then you measure the length of the straight line, then you say it is like 10 centimeter, something like that. So means in every day we compare, we measure various things. So whenever you measure, what you do is you take one unknown quantity, because we don't know what is the amount of that quantity, and we compare that unknown quantity with this known quantity. They are the known quantity. So after comparing the unknown quantity with the known quantity, then you will know the amount of unknown quantity. So that process of comparison of unknown quantity with the known quantity is known as measurement. And it helps to know the amount of substance. Why measure? To know the amount of substance. And there are some importance of measurement. Without measurement, you cannot sell and buy the goods. That's why it helps in selling and buying the goods. And if you want to do some experiment in your lab, then we take the measurement of different chemicals and then we do the experiment. Similarly, it helps to understand the amount of substance, like how much amount you are going to take. Maybe 2 kilograms of rice, maybe 10 kilograms of rice. And it is important in health sector for the treatment of disease, because you will be given medicine, you will be giving medicine to your patient, and then what you do is you take the measurement of your medicine and then give medicine to patient accordingly. Types of quantity. There are two types of quantity: physical quantity and non-physical quantity. Whatever the quantity that you see around, if we can measure, then it is called physical quantity. Example, uh, like a stone. We can measure the mass of a stone. We can measure the volume of a stone. We can measure density of a stone. So since we can measure its quantity, then it is called physical quantity. So example, length, we can measure length, we can measure mass of the body, we can measure the time, we can measure speed, temperature, force, pressure, electric current, etc. So these are the physical quantity. And physical quantity is for the two types, fundamental and derived quantity, which we'll be discussing in next slide. Non-physical quantity, just opposite of physical quantity. Here can be measured, here cannot be measured. So the quantity which cannot be measured is called non-physical quantity. So what kind of quantity that we cannot measure? Like love. We cannot measure love. Hate, ambition, greed, anger. We cannot measure them. That is why they are called non-physical quantity. Fundamental quantity. So there are so many quantities that you see around us. So that quantity is called fundamental quantity, which is independent of other physical quantity. Means it doesn't depend upon other. Example, length. So if you want to measure the length of any object, you can take the scale and measure it directly. Similarly, if you want to measure mass of any object, you can take the device and you can measure the mass directly. Time, you can measure the time directly by the watch. Temperature, you can measure directly the temperature by thermometer. So means here If you want to measure length, mass, time, whatever the quantities given here, that can be measured directly because they are independent. It doesn't depend upon other physical quantities. And there are 7 different fundamental quantities. What are they? Length, mass, time, temperature, current, electricity, luminous intensity, and amount of substance. Derived quantity is just opposite of fundamental quantity, the physical quantity which is dependent to other physical quantities. So it is independent, it is dependent. Example, area. Can you measure area directly? No. If you want to measure area, then if you remember formula of area, then length into breadth. So if you want to find the area of any certain place, then you have to know the length and breadth. You have to measure length separately, breadth separately, and after multiplying them, then you get the area. So like here length, area we cannot measure directly. That is why area is derived quantity. Similarly, volume. Volume formula, if you remember, length into breadth into height. So you cannot measure directly the volume. Acceleration, change of velocity per unit time. So if you want to measure acceleration, you have to know the value of velocity, you have to know time, then only you can measure acceleration. So what does it mean? You cannot measure these quantities directly like length, mass, and time. That's why they are derived quantity. Why you cannot measure them directly? Because they depend on other physical quantity, like area depends on length and breadth, volume depends on length, breadth, and height, acceleration depends on velocity and time. That is why these quantities are called derived quantities. Unit. So unit helps to know the amount of substance. Like there's one. If you remember, check the digit one. If you say 1 gram, if we say 1 kg, if we say 1 ton, they all give different amount. So that's why quantity, which helps to know the amount of substance, is known as unit. There are 4 system of units: MKS system of unit, CGS system of unit, UPS system of unit, and SI system of unit. Let's describe one by one. So in this system of unit, we describe 3 physical quantity: length, breadth, length, mass, and time. So in MK system, what we do, here M means meter, K means kilogram, S means second. So in MK system, length is measured in meter, mass in kilogram, and time in second. So in MK system, the system of unit in which length is measured in meter, mass in kilogram, and time in second is known as MK system of unit. And it is also known as metric system of unit. If you go to CGS, then length is measured in centimeter, C means centimeter, mass is measured in gram, and time in second. Similarly, in UPS system, length is measured in foot or feet, plural is feet, mass in pound, time in second. So the system of unit in which length is measured in centimeter, mass in gram, and time in second is known as CGF system of unit, and it is also known as French system of unit. In UPS system of unit, the system of unit in which length is measured in foot, mass in pound, and time in second is known as CGS system of unit, and it is also known as Britain's system of unit. So a pound symbol is LB. So why the symbol of pound is LB? Because it is taken from Greek word libra. So that's why symbol is LB. Now the last system of unit is SI system of unit, and this system of unit is internationally used. The reason is it can measure all the physical quantities. If we see in the first, these all 3 system of unit, they can measure just length, mass, and time. But in our surrounding, there are so many other quantities. That is why SI system of unit, it is internationally accepted. The reason is it can measure all the quantities that is around us. And this system of unit is not new system of unit. It is the system which is derived from the MK system. It is developed from MK system. And it is 2 types again. namely fundamental unit and derived unit. So fundamental unit, as we discussed before, fundamental quantity. So definition is somehow same. So the unit which is independent to other units means this fundamental unit does not depend upon other units. And why its name is fundamental unit? Because this fundamental unit measures fundamental quantities. And as we told you, there are 7 fundamental quantities, and their unit is called fundamental unit. So length, meter, mass, kg, times second. Why? Because it is derived from MK system. Temperature, Kelvin. Current, electricity, ampere. Luminous intensity means it is related to light, so candela. Amount of substance, mole. So these 7 quantities are physical quantities and their units are called fundamental units. Since a quantity is independent, their unit also independent. Here you can see meter, it doesn't depend on anyone. Kg, it doesn't depend on anyone. Now derived unit. So the unit which is obtained by combination of fundamental units. So when you combine 2 or more fundamental units, then you get derived units. Example, area. Area means length and breadth, and you know length unit is meter, breadth unit is meter. So the unit of area is square meter. So here see meter and meter. So it is depending upon 2 fundamental units. That's why meter square meter is derived units. Similarly, velocity. Velocity formula is length distance by time. This distance is meter and time is second. So that's why velocity depends on meter and second. That is why the unit of velocity is derived quantity. Name the fundamental units involved in derived units. So here this question can be asked in exam. Suppose you are asked this formula and you may be asked what are the fundamental units involved in it. So it is very easy because here units are visible. So all the time take the help of formula. So cubic meter is the formula of volume. So length into breadth into height. So meter, meter and meter. So that's why fundamental units involved are meter, meter and meter. But joule, here fundamental units are not visible. So here you have to be more careful. So joule is the unit of work. Work. So always take the help of formula. So work formula is force into distance by time. Now convert the formula into simplest form. So work equal to force means ma into d by t. So this is the simplest form of formula. Now keep the SI unit. SI unit of mass is kg. Acceleration unit is meter per square second into, and distance means meter per and second. So in conclusion, kg, meter and meter means square meter, per second square and second becomes cubic second. So in total, it becomes kg square meter and per cubic second. So what are the fundamental units involved here is kg square meter and cubic second. So in this way, you can find the fundamental units involved in derived units. So with this, I want to wrap up session 1. Thank you.